everybody, and welcome to our 3 o'clock, what is today, Dino talk. You're joined by myself, James, and we have Ben behind the camera.
Howdy.
Who is going to be talking about one of the dinosaurs later on. But without further ado, we will get started. So, I'll tell a bit of a lie actually, because it's our Dino talk, but this isn't a dinosaur. So for those of you that don't know exactly what we do in this little talk, which we've only recently started doing,
Ow.
Ben Falls, is we've gone into our Lost World dinosaur barn, and we're essentially making our way through all of the dinosaurs that we've got in here, telling you a little bit about them, suspected about them, and yeah, giving you a little insight into what their lives might have been like. So starting with this guy here. So this is a Pteranodon. They are, as I said, not dinosaurs. They are part of a larger genus of pterodactyls, which sort of splits off into a few other groups, so like your Pteranodons and then your pterosaurs. So those are the two main groups, and I'll talk about the differences in a minute. But this is sort of the key shape and design for these Pteranodons. So if Ben would show you.
Lee says hello.
Slowly. You can see, obviously it's quite large, this is a lot larger than anything that would be alive and flying today. And the reason for this is they had a much different approach. These are actually believed to, although in the early Jurassic period it was suspected they may have started to develop it, the majority of them were featherless, and they were flying using, basically what is making up their wing is a fleshy membrane, almost like what you'd see on the, oh, that's quite cool, I thought it would be solid plastic.
No, fleshy membrane.
Quite like what you'd see on the frill of a frilled lizard, something like that, but obviously a lot stronger.
This is in the Dino barn, just to answer your question, Casey.
And these guys are, I think, really, really interesting, but given the fact that they are reptiles, flying reptiles, and they sort of changed over time to become, well, the majority of them became things like birds today. They, in those new environments which me and Ben talked about on length in our last week's video, but as conditions got a lot harder, they have adapted. By doing so, they actually got a lot smaller, and it's believed they developed feathers for like insulation and to help keep them sort of. It's argued whether it was purely for insulation or that far back things like dimorphism and using it to attract mates had already started to come in. But with these guys, at their time, they are, as I said, completely featherless, and the head is probably the most recognisable and striking part of this sort of family. They have that lovely long crest on the back of their head, which is believed to be brightly coloured and sort of hollow. In different species, it was argued to be hollow or solid. It was actually believed in quite a lot of the cases, however, to be used as a counterbalance to help them stabilise themselves in flight. The next thing I do. Now, this is something very sort of characteristic for the Pteranodons, but if you talk about the other species within this family, it does change massively. So these guys, what they would be seen doing is flying over oceans, essentially looking for fish. And it is believed that the way their arms are built, I'll talk about that in a second, that they were capable of doing something very similar to cormorants and gannets, where they fold their wings up, dive into the water, going after those fish. That's another suspected reason for the crest, to help give them a little bit of extra weight in the head to push them down further when they do that diving motion. But these guys, they have that long beak, it makes it a lot easier to catch fish in. Obviously it's bigger, that means more surface area, more chance for them to catch something. However, if you're looking at some of the other members of the family, an example of this would be things like the Dimorphodons, which are a lot smaller. They'd be about the size of a beagle, but they had a very, very different shape to this. They were much more sort of haunched over. Their wings were a lot bigger and actually spanned from their back legs to their furthest out index finger. Do we have a question?
We do, and it fits really nicely into what you're saying, which is why I thought I'd ask it now. So obviously these guys, it's attached to the wing, to the base of the tail, etc. How would that affect walking? So Eric's asked, how well would they move on the ground? So your pterodons, etc. How manoeuvrable would they be?
Right. In all cases, they're going to be pretty slow. They're not quick moving on the ground. Something like this is going to land to rest. If it needs to get out of a situation, it's going to fly away. So they don't have to be quick on the ground. What they tend to do is they'll curve like an elbow joint their toes, I guess? Fingers? Their fingers.
Phalanges.
Phalanges. You can't go wrong with phalanges. The phalanges will be down and they basically act like a forward appendage, allowing them to walk. Whereas the things like the dimorphodons, those smaller species that have much, in comparison to their body, have bigger wings, they're almost completely useless on the ground and have to scuttle, more like, because they are built for climbing. It's believed that they didn't exactly fly as such. They could, but it would be a bit more like most sort of poultry flight, where it's very energetic and quite staggered, and they can't do it for very, very long periods of time. They're gliders. So those smaller species, you'd see them, all of these guys are predators, none of them herbivores, and they will basically hunt small little insects off the wing. But their jaws and their mouth, they'll be a lot similar to something like the raptor, where it's not as long, quite a bit stockier, and they actually do have teeth. Actually, talking about, I'll go on to that quite quickly. If we're talking about this, the appendage that is the wing, and this is the same for birds today, it is actually exactly the same as the setup in terms of what bones are in it as our own arms and legs. And not pteranodons, pterodactyls, they actually come from the Greek meaning of winged finger, which is because what would make up this supporting bracket along here is essentially, it's not phalanges last, is it? No, it's phalanges last, isn't it?
Yeah.
Yeah, which would be exactly the same type of bone as our phalanges, so the tip of our fingers. And if you looked all the way through back to the centre of its body, it'd be almost looking through a exact copy of our hand. This is called pentadactyl limb, and pentadactyl limbs can almost be seen in every vertebrate animal. It is an essential setup, and it's an example of conjunctive evolution where nature has sort of realised the design that it's perfect, and it just sort of keeps coming up because it really works. So that's why you see a lot of animals with similar designs with slight differences. But yeah, these guys, it's believed that they slowly started to evolve to have feathers and became a lot smaller. But an example, one of these guys is something called Quetzalcoatlus, which is believed to be the largest flying animal to ever have existed. It had a body length, so from the top of its beak to its back feet, so it didn't have a tail, was the length of two school buses. No, two double-decker buses, wasn't it? And its wingspan would have probably been about the size of this barn, really. They were absolutely ginormous, predominantly hunting things like large fish. I've only just realised that we have.
Yeah, we do.
But yeah, they'd hunt those large fish and sometimes large marine mammals. But yeah, they truly are really, really cool, and these are the sort of guys that you see living today. And they're pretty much what passed on the genetic code that led to birds, which is absolutely fascinating. And given the fact they fly, they can be found pretty much everywhere. Although the largest ever found dig site colony of flying reptiles was in Germany. It had over 400 different specimens of all different ages. So it's believed that there was a sort of setup, and maybe it was once a mountain or surrounded by a land, which is quite cool. But do we have any questions?
We have one more question. That's from Joanne. Do you think scientists will manage to clone a dinosaur one day?
The thing is, Jurassic Park got it quite right in how it would have to happen. Maybe a bit iffy with the mosquito, but I think it was 2012, the woolly mammoth?
Well, the one that they found pretty
Yeah.
much preserved.
So, for those of you that don't know, in whatever year a young woolly mammoth was found that was preserved in ice.
So it was earlier than that, 2008?
2008, yeah. Yeah, it was probably earlier than that.
Because Dolly was 2006, I believe.
Yeah. So when cloning was sort of becoming a thing that people were knew about on a much larger scale, and it had skin tissue left which in our skin it contains DNA, and it would be very simple for them to take a bit of that DNA and reproduce it, and you just have to use something like a surrogate mother in the form of an elephant, which would be perfect. But there was this whole ethical debate about whether it would be right to do it, given the fact that the climate that animal survived in at its time simply doesn't exist anymore. But per se, if they found living tissue of a dinosaur that had DNA within it, they could in theory clone that animal. But that's a big if.
More likely what we're going to see potentially in recent year, in the next few, years, decades, will be less dinosaurs, more things that have gone extinct relatively recently. I think they cloned an Iberian oryx. I think that's it. It was that they cloned that. I think it's lung collapsed pretty quickly, but they did breed well. So I imagine it will be a matter of you get animals that have recently gone extinct, or even you have such a small MVP, you've got such a small genetic pool that maybe they start looking into it. But what's the point? Because they're all related. Yeah. It's only going to take one disease to wipe them out. That's, I think, what you were saying about the ethical debate. It's a novelty rather than a...
There's lots of things going on, because technically, if you go down the whole genetic route of it, technically you can modify genomes, so it would technically be a different animal if you clone two of them, but that's millions and millions of pounds to do that for a very little result. Like, it would cost absolutely ridiculous amounts of money to clone that mammoth and then make another one that's slightly different, so that the inbreeding percentages would be slightly less. But you're never going to get that to be a completely different creature, so it's always going to be a risk. And we're not perfect at it. Cloning is still one of those things where people are figuring things out.
Like VR.
Like you just said with the Siberian
oryx. I think it was I think it was the oryx.
Yeah. So there's certain things that still need to be developed. That's something I didn't think I'd be talking about cloning today.
I'll tell you what, it'd be cool if they did thylacine, which was the Tasmanian wolf. That'd be a pretty nifty thing to see.
Yeah.
What would you most like to see? Not dinosaurs, but sort of megafauna, that sort of thing. Or brought back.
Terror birds.
Oh, you quite like the terror birds?
I like terror birds. Or saber-tooths. There was this whole... It wasn't the dinosaur era, it was when the mammals and birds were starting to take over.
Miocene?
Sounds right.
Yeah, I think it's about that.
And back then you just had mammals figuring out how to do it best. And some of them were way over the top. Like, for those of you, like saber-tooths and terror birds, for those of you that don't know, terror birds stood about that tall and were basically killer ostrich. Even more killer than our current ostrich. They had massive beaks. They could just tear things apart. They were predominantly scavengers.
They weren't massively rat-like, were they? They pecked. They didn't have the killer foot.
No, they could peck, but they could run at about 40 miles an hour for a long time. But all the saber-tooths killed them, so...
Yeah. Don't know, I'd probably like to see... Passenger pigeon would be quite cool to come back at its previous quantity. Just miles of them. What else? I'm trying to think. There was something cool. Giant sloths are pretty cool.
Yeah.
I quite liked them.
Yeah. There's quite a lot, like I said, when the mammals were figuring it out, starting to get a proper foothold in the world, there were some crazy things walking about. Oh, what was it?
Haast's eagle.
Yes.
That would be cool.
There's a species of eagle, the Haast's eagle, which had, I think, 5-metre wingspan.
Hunted the moa bird.
Yeah, which is just ridiculous.
I mean, literally, they had a skeleton of it at the Natural History Museum, and you're literally talking...
Probably about that big, or bigger than that.
Literally from the ground, maybe another head on top of that. Like, it was just ridiculous. But I think, would you have wanted to work at Jurassic Park? If they got their IT systems up to a bit of a better standard and their ethics, then yeah, I'd probably give it a go. Yeah. Am I kidding? Well, I was wondering if it paid better. Like, would you get paid more to work with dinosaurs, or would it be like we spent so much money cloning these dinosaurs?
Well, we can't afford to. Well, just be us, but getting bitten by, I don't know, triceratops when we're not looking instead of a skunk.
I posted on Reddit, and it was like, I think Jurassic Park, their official page posted, which was like, oh, we also have an invert room.
Oh yeah, I saw that.
I would love to see the Jurassic invert room, because inverts back then were massive. You had dragonflies the size of, planes. Like, that would have been cool.
Oh, we have a question quickly, one that I think you'll like from Eric. Where do snakes appear in the timeline of history? And tell us a little about those prehistoric snakes.
So, snakes are an interesting one, and I will get James to nod and make faces behind the camera to see if I'm getting it right, but I believe snakes were first.
Before what?
Lizards.
Lizards, yes.
Yes. So, no, they were not. They were after lizards because they lost.
No, they had two at the time. So there were two groups of snakes that evolved. That's one of those things that was on about where evolution figures something out and it's like, I like that, I'll do that again. Where you had snakes, there were snakes that evolved from, I don't know, angry worms, and then you had lizards that lost their legs.
Yeah. So, your prehistoric snakes were quite interesting because there is a fair amount of research into them, but the problem is because everybody likes the exciting ones, a lot of the research has gone into things like, I'll use the common name, which is Titanoboa, your giant sort of 100-foot odd snakes. They're absolutely enormous and, yeah, probably did play quite a role in Jurassic times. But if you think about the sheer quantity of species of snakes in the world at the moment, when dinosaurs, they're not, obviously not still here, and you haven't still got the huge diversity of food about, you must think that back then there must have been a much, much higher quantity of species. We just don't see that represented in research. You mainly see stuff on the Titanoboa and those giant snakes, but they were pretty amazing. I mean, you know, snakes that take out, well, you could take out dinosaurs, a dinosaur-eating snake. I mean, that's pretty impressive. But it was constrictors first, I believe. So you had your constrictors, your big thrashers, and then over time, what would have likely happened was what's happened with the Komodo dragon. So yeah, the Komodo dragon does have very, 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 very tiny venom glands, but most of its damage comes from bacteria, so it has a really high quantity of bacteria in its mouth. This basically, when it bites a water buffalo, basically that bacteria sets in, causes septic shock, etc., and kills it in a couple of weeks. Over time, that would have developed, and what you've seen is more proteins would have been developed. You'd have seen enzymes and proteins and things developed, and you've got to think it's over millions and millions of years, you would have started to see a more sophisticated form of venom appear. The two main types of venoms you really get at the moment are your neurotoxins and your hemotoxins, and when things branching off them. So your neurotoxins paralyse, your hemotoxins eat away at the flesh. There are lots of other cytotoxins to the heart, etc., but I'm not going to get into venom.
Before you move on, as it's on the subject, can you do an impression of an angry worm? I'm just going to grr.
Yeah,
there you go, the angry worm.
Right, so this here is our Brachiosaurus, but we're not going to call this a Brachiosaurus. What we're going to call this is a sauropod, because I'm not interested in Brachiosaurus, but I do love sauropods in general. So, your sauropod, I would say, next to the T-Rex, the most well-known dinosaur on the planet. They are the giant, long-necked, think the dinosaur, land before time dinosaurs that everybody kind of recognises. They are absolutely fantastic. They are probably one of my favourite sort of dinosaur animals because they're just so immense, but also they are so fundamental to the story of the Jurassic, the Triassic, etc. Because they were there pretty much throughout, and they were incredibly successful. They were there right at the beginning of the early Jurassic period, and they're clade. They're sort of, they clade their family, if you will, which isn't the right word, but the group that is your sauropods, they were so diverse. You'll normally see things like your Argentinosaurus, your Brachiosaurus, your really big, sort of quite well-known, impressive ones, but there were just so many. All had adapted to eating slightly different plants, all had adapted to hunting in different ways. So most of them, though, they followed similar characteristics. And we'll do a similar thing. I was going to do a similar thing as to what I did with the T-Rex and make my way down. I'll do that slightly, but we're going to start with the head. The head is really important. It's actually cooler than you think, because the head in general is actually quite small in comparison to the rest of the body. They don't need a particularly big head. It is the thing that goes in. It's the thing that all the food goes in, but it is quite clever. Not the biggest of brains. They were relatively clever. It's thought like elephants. They would return to nest sites. So they would return to the sites that they nested. But there is a theory at the moment, and of course, being that it was 175 million years ago, not longer, that they were around. This is all conjecture and obviously based on research, but you know, it's largely based on a little bit of guesswork. And a lot of our research on dinosaurs is based on what we have today. And we apply what we know from the animals we have today to our dinosaurs. But it is also thought that not only would they return to the places they were born, which you can kind of understand, maybe they remember, but they would also return to the places that their parents would have bred. And that's what's cool, because it may have learned that from other members of the herd, but it may also be an innate instinct, which is really, really clever. Do you have a question?
No, I've turned it round on myself.
Oh, hello. So that's pretty clever, and pretty clever from an animal which has quite a small brain in comparison to the rest of the body. Moving away from the brain, we're going to talk about the teeth. The teeth are impressive. So they're going to be stripping things like ferns and early trees, but mainly ferns and things, of all their leaves, and they're going to be munching away at them. Now they need to eat a colossal amount of food to fuel that enormous body, which means the wear on the teeth is pretty extensive. Now, much like sharks, they replace their teeth at an incredible rate. In fact, it is thought that they would replace one tooth every 14 days or so, which is an incredible rate. So they would regrow their teeth very, very quickly, which is pretty impressive. Moving down, we have the neck. And the neck is what has kind of led, one of the things that's led them to their success. It's one of the things that's most well known about them. It's also one of the things that gives us it has the most conjecture among your sauropods. But that neck is really impressive. Obviously, it works in a similar way to a giraffe in regard to sort of niche adaptation. The higher on the tree, the higher on the branches you can go, the more you're going to be able to take that other animals can't. If you've got a longer neck, you can eat those leaves, you get to the top of those trees that other animals, other dinosaurs, they can't reach. So a typical sort of defining feature of your sauropods is that long neck. Now, the neck is an interesting one, and it has led to a few different theories about them, many of which have been questioned. So, first of all, their stance. If I could get you to jump out here, James, and show us the stance on the, what was it,
Brachia, I think.
No, there was no brontosaurus, was there?
What do you mean?
There was no proper brontosaurus, was there?
There was a brontosaurus.
I swear I heard something was actually brontosaurus and two different things.
Sounds like something. Yeah.
Yeah. So, see, that lovely neck is basically, this is the stance that we would have seen on Jurassic Park, Jurassic World. And it's largely thought that, Brachiosaurus is the main species, but the vast majority of sauropods, they would basically be one long line almost. So they had a very, very long neck, but when they were moving about, when they were walking, the tail would be almost in line with the head, so it'd be like that rather than like that. And that's based on a few things, but one of the ways they've actually worked that out is by footprints. The depth of the footprint would be a lot heavier at the front if they walked along like that. So you'd see deeper footprints, you'd see different definitions to the footprints as you would on traditional sauropods. So it's thought that some of them were more like that, but most of them were horizontal. Obviously the large feet, normally larger at the front, smaller at the back. They need those large feet to obviously displace the weight, that immense amount of weight, up to sort of 40 tons or more, much more for some of your bigger species. I mean, your largest one was Argentina? Argentinosaurus, wasn't it?
It might have been Titanosaur.
One of the two, Argentinosaurus or Titanosaurus, and that was I think 50 metres, which is about 150 feet or something. To put that in perspective, the largest terrestrial animal is about 35 feet, which is your reticulated python. So they are the biggest things to ever walk the earth. They're absolutely enormous. And then we've got the tail, which we kind of went into. Again, it's going to be mainly there for balance. Again, one of the reasons why they're going to have that nice long tail. Quite short on Brachiosaurus, actually. But on your other sauropods, much, much longer. Works as a counterbalance, helps balance out that enormous sort of front. But again, the small head does mean they didn't have the same problem as, say, the T-Rex. And the last thing I want to talk about very, very briefly is some of the misconceptions with the sauropods. So we covered the stance. What we want to talk about is also where they were found. Now, most of you, a lot of you growing up, if you'd seen them in a picture book or you'd watched them on, well, I watched the Dinosaur and things like that. If you'd, or what was it, Lost Planet? No. What was the one with the cartoon dinosaurs?
Oh, there was Land Before Time.
Land Before Time. So if you've watched stuff like that, or you even sort of gone through the old picture books of dinosaurs, these guys would have always been found in water. They were usually found floating sort of up to their middle in water, feeding on trees in swamps, etc. And it was thought that because of the sheer size of these guys, they just couldn't walk on land. Their body wouldn't support that immense weight. So there would be water to displace it. And in fact, what they found was over time, that perception has changed. They worked out, first of all, the stance would have helped incredibly. They'd also found that there had actually been a lot of complications with them being in water. With them being half submerged and how big they are, they'd be at quite a depth, which would actually put a tremendous amount of pressure on their organs. So in fact, these guys were heavily terrestrial. A lot of them weren't semi-aquatic, as we originally thought. So that is pretty much it for our dino talk. I hope you enjoyed it. Have we got any other questions? We do. We have two we can quickly go through. Eric Knight asking, given the vast amount of plants that they must have eaten, the plants must have grown, must have had incredible growth rates. Would it be possible to reproduce that? Artificially, potentially, but the reason that we had such large animals, as James was saying, the Miocene, when we had our large mammals, the reason these animals got so big was because the atmosphere was different. We got a lot more oxygen, which oxygen just allows things to grow bigger. And again, then for our, there'd also been a fair amount of carbon as well, which would have helped our plants. But you also, a lot of the plants that we had at the time are things like ferns, sort of early ferns, early trees, etc. And they grew incredibly quickly just due to the atmosphere being so different. So we could recreate it, but we couldn't recreate it naturally. We'd have to do it artificially. But yeah.
And then Joanne asking, would they have a large territory?
Would they have a large territory? I'm not 100% sure. They were migrants.
Yeah.
Weren't they? They just follow the rains and they follow.
Yeah, because of the amount of food that they simply ate. If they stayed in one spot, they'd very quickly run out. Because they are herd animals. There'd be up to 100, 200 of these things bopping about together. So they were constantly pretty much on the move, following, as Ben said, the rains and different season changes to keep up with their stomach, basically. But yeah.
I will also very, very briefly talk about, there's been some conjecture to species, what were thought to be juveniles of the same species have actually recently been identified as having something called island dimorphism or island dwarfism, where being on an island, less food about, they just adapted to be small. So it would have been, the same species, but it's on a different island. But it gets separated over many, many years. It adapts to live slightly different in smaller sections. Same interesting for our show now.
Which, speaking of, we probably need to
we need to
go and feed.
So thank you very much, guys. Any other questions, please put them in the comments. And this will probably be the last Dino talk for a while. And probably our last Saturday talk for a while. We'll come back and do some conservation live streams. It's been a pleasure having you here with us for the last few months and joining us on a Saturday. And we look forward to seeing you all in the flesh, hopefully, this Thursday or Friday.
Hopefully see you soon, guys. Goodbye.